TPU is an excellent 3D printing material. It has a lot of properties that are incredibly useful, including perfect layer adhesion, which is unusual among 3D printing filaments. But it's always had a very large challenge for the consumer or hobbyist. Mostly, the biggest problem with printing with TPU is that it's very difficult to print with supports. So any 3D printed model that you're going to print that uses TPU usually needs to be extremely simple and straightforward, unless you have the ability to print with multiple materials that includes TPU. Some single extruder printers do have multi-material systems like the Bambu AMS, which is incredibly useful, but TPU is just not compatible with it. A lot of people have tried some very interesting mods in order to make the AMS compatible with TPU, but the reality is that pushing a kind of floppy filament through the AMS often does cause a jam. And I've done lots of experiments attempting to make it work, and unfortunately, it just is not realistic. Even in your best case scenario, you're going to run into routine failures, which means that if you have a print that needs to change between TPU and another material frequently in order to, for example, print supports for TPU, your print is extremely likely to fail at some point in that print. And so it's just not worth it to attempt to print with TPU and another material unless your printer has more than one hot end. The Bambu H2D, which is the printer that I'm currently using, does have two hot ends, which opens up a world of possibilities for printing with TPU, because now I can print models that can be supported with materials other than TPU. TPU's perfect layer adhesion is also a weakness, because any supports that you print that use TPU tend to bond perfectly to the model and become inseparable. And so what you'll see is that a lot of makers or bloggers will use angle grinders to shave off their supports. Even under those circumstances, they tend to not get great finishes. And if they do get a great finish, their model has to be very simple, right? With no like hidden corners, no like hidden supports. They have to be very accessible to something like an angle grinder from the outside. So using a printer that has multiple hot ends, like the Bambu H2D, does make it possible for us to experiment with different support materials that we can use with TPU. Bambu attempted to address this problem by introducing a material called TPU for AMS. That material is interesting. It does work with the AMS and it is a TPU, but it's not exactly a typical TPU. It is a kind of TPU alloy. First of all, its Shore durometer rating is extremely high. I haven't measured it myself. I do have a Shore durometer gauge, so I could measure it, and I will someday. But they don't advertise it. They don't say what it is. My guess is that it's somewhere around 98A or maybe even a little bit higher. I don't think that it's the same material that they're using in their 95A high flow TPU. It appears to be an alloy. Maybe it has PLA in it. It might be a flexible PLA. It does work well with the AMS, and it does make it possible to print models that use supports that are not TPU, and that's a huge benefit, right? But as far as TPUs go, it's just not the best TPU. It's not that flexible. Its layer adhesion is not as strong. It is not as grippy or rubbery as some other TPUs are. So it's not my favorite material. If we can print with regular TPU, that would be my preference. One of the other major limitations of TPU is that it's not compatible with every build surface, right? So if you are using, for example, BQ's cryo line of build surfaces, TPU is not advised to print on those directly. And the same goes for any PEI-based print surface. So the print surfaces that are available for the Bambu H2D are both PEI. PEI is a wonderful build plate material. It has a lot of great material properties, like its ability to expand dramatically when heated. This means that as this material cools, it will shrink quite a lot. And if your model that is being printed on PEI doesn't shrink at the same rate that the actual build plate does, it will kind of detach itself, which is an incredible advancement in build plate technology. Years ago, this was not possible, and you had to scrape your prints off of your build plate, usually damaging the build plate, or you had to kind of deal with less adhesion to your build plate and kind of roll the dice on your prints detaching in the middle of their print. But PEI makes it possible for your prints to hold extremely well and then release when the printing is done. But this is not the case with TPU. TPU is flexible enough that when the build plate collapses, the print still holds tight to it. And so it's not advised to print TPU directly onto a PEI sheet. So with the Bambu H2D or any printer that has more than one nozzle, it's a really good idea that if you're going to print in TPU that you use rafts. A raft is essentially just a layer that is solid that goes directly under your model that's being printed. And you can choose a different material to print that raft in. And so we're going to do some experimentation in which we're going to print some TPU models that have TPU supports, but are using a different material for a raft base and for the interface between the TPU support and TPU model. That should show us which materials, first of all, are good to print on with TPU, and second of all, which materials release easily from TPU when they're done printing.
All right, so I think that most YouTubers would withhold their results until the very end because they want you to be kind of captured to see what the outcomes were of all their testing. I'm not going to do that because I'm not monetized and I don't care how much you watch. So instead what we want to do, I think, is present the results that I got, make some recommendations about which materials are the best materials to use as supports for TPU, and talk about which settings worked the best for those different materials. And then if you want to watch till the end, then we can actually talk about the individual test results. There's some, little tidbits of additional information that I included during the tests, but it might not be worth your time. So every combination of support material and setting, Z distance setting, was graded using 4 subjective metrics. The first is the model quality, the second is the adhesion to the build plate, the third is the release from the build plate, and the fourth is the release from the model. So if it released easily from the build plate and model, then it got a 10 out of 10, and if it did not release at all, it was permanently bonded, then it got a 0 out of 10. Adhesion to the build plate meant that it didn't slip off the build plate, so that's a suitable raft material. And then model quality, I think, is pretty self-explanatory, but again, they're all subjective, based on my intuition of what I think was best and what was worst. The materials that did the best by far, or I should say, yeah, by far, let's say by far, there's really 4 materials that I think are really incredible support materials for TPU. The first are the 2 dissolvable materials, which are BVOH and PVA. And then PLA and PCTG were also very good choices. Now, the dissolvable materials, BVOH and PVA, are very difficult to work with. You have to dry them out. They have a tendency to jam in nozzles when just slightly overheated. Sometimes they don't. Like if you have any moisture in them at all, you'll get like weird artifacting with them. And for that reason, I would suggest that unless you're specifically working with a model where quality just cannot be compromised at all, or if you have hidden supports that are not easily removable, then I would say stay away from these dissolvable materials, right? I would suggest using PLA as a matter of fact. PLA had the best result. PCTG was not far off as far as materials that are very easy to print goes. And maybe I need to add a fifth subjective rating, which is ease of material utilization or something. But as you can see from these results, BVOH and PVA take the first 5 spots. Essentially, Z distances of 0, 0.1, and 0.2 for PVA and just 0.1 for BVH were all among the top results that I got. Essentially, our scores of 38, there's 3 that are 38, and those are BVOH with a Z distance of 0, PVA with a Z distance of 0, and a Z distance of 1. Just slightly worse than that was a PVA with a Z distance of 0.2, and then BVOH with a distance of 0.1. But PLA was also an excellent choice. With a Z distance of 0, the model quality was still extremely high. It just was a little bit, maybe slightly more difficult to remove from the model than the PVA is, because we could always dissolve the BVA if it ever over adheres. Then we go back to PVA at 0.3 was also extremely high quality, BVOH at 0.2 extremely high quality, and then PCTG with a Z distance of 0, also a very good material. With a Z distance of 0, you still get an excellent result. The only difficulty is that you have to do a little bit of work to release it from the model. Then we have another PLA setting of 0.1, but I would say if you're going to use PLA or PCTG, using 0Z separation is the way to go. And that's also the case for PVA and PLA. PVA and BVOH. I would use a Z distance of 0 in order to support those. That is not true for all of them, though. Once we get down into materials like nylon support by Polymaker, this was actually a surprisingly decent material to use as a support material for TPU. The model quality wasn't perfect. It wasn't that easy to remove from the model. But using the Z distance separation of 0.2 did actually have the best result. So if you end up in a situation where you have to use this material because you don't have PLA and you don't have PCTG and your PVA is wet, or you don't have BVOH on hand, nylon support will work. It will work, and it's not terrible. Not a bad choice. Not as good as PLA, though, so definitely prefer PLA. When we go down a little bit further, we get into PLA support by Polymaker. Essentially, all of these settings ended up having the same approximate score. I would say pick one based on, would you rather have a higher model quality or an easier time removing it from the model, right? Because with a very high model quality at 0.1, you're going to have some work to do to remove this support. But you can easily remove the support at 0.6 and not see, you'll have semi-acceptable, not excellent model quality, right? So this could work. I would say probably not the best choice of material if you're actually going to pick a material to support with. Then we get into the new PLA support material by Bambu Lab. The best option here was 0.5 Z distance separation. That's pretty high, so model quality definitely does suffer, but it removes easily from the model. Then we get into actually using actual nylon as a support material. This is not a great support material. Basically anything in the low 30s and below is going to be a really bad choice. So, and this is definitely one of those. I would say don't use this material, but if you did, you could use 0.3 Z separation if you want to easily be able to remove it from the model, or 0 if you want a high quality model and don't mind doing some work to remove those supports. What else have we got? We've got polycarbonate barely worked. I'm not even going to go into detail on that. Let's get down a little bit further. Self supports is somewhere around here, 26 or so. Terrible choice. Don't use TPU to support itself. It bonds too strongly. It's too difficult to remove. The model will suffer dramatically as a result of it, and so you have to pick a Z separation of at least 0.5 in order to even get it apart. You're going to have to do some real work to do that even still, and the model quality is going to be bad. So TPU does not do a good job of supporting itself. Let's see. And then we get into the stuff that just didn't work at all. So high impact polystyrene did not work. That's a score of 0. Bambu's nylon support did not work. yxPolyer's nylon support did not work. And ASA by Elegoo did not work. So I would not use those materials. And then to kind of just take an overview, never mind the settings, just which materials work the best. As you can see, BVOH and PVA are tied, and then the next highest scores belong to PLA, and right behind it is PCTG. This other stuff that's kind of middling, the nylon for by Polymaker, nylon support for Polymaker, and PLA support by Polymaker are tied. Bambu's New PLA Support and nylon are equally right behind that. And then we have polycarbonate behind that, and then self-supports behind that, and then these just did not work at all. Okay, let's take a look at the actual tests. And
Okay, let's talk about PVA supports with TPU. So PVA is polyvinyl alcohol. It's a dedicated support material. The PVA that I'm using is made by Bambu Lab. PVA is the same chemical that's used in glue sticks, the glue sticks that we use to prep a print surface so that our prints both stick to it well and also not permanently. It's also the same material that's used in Tide pods and dishwasher detergent pods. So it's a pretty incredible material because it is water soluble, which opens up a whole world of possibilities as far as 3D printing with supports goes. It makes it possible for us to put supports inside of a model that are otherwise completely inaccessible, that we would not be able to remove, and still support our model and remove those supports by dousing them in water. PVA is a much easier support material to print on the Bambu X1 carbon than it is to print with on the Bambu H2D. And that's because the Bambu X1 carbon has an incredibly accurate hot end. The hot end usually moves exactly to the temperature that it's targeting, and then it stays there without going dramatically over. That is not the case with the H2D. The H2D's hot end tends to overshoot its target temperature quite dramatically sometimes, and then have to back off in order to get to the temperature that it's actually attempting to reach. And so the result is that sometimes when the H2D is preparing a nozzle to print with the PVA, it puts the nozzle temperature all the way up to about 250 degrees Celsius. And if it overshoots that temperature by a dramatic amount, say 10, maybe even 15 degrees, getting into the 260, 265 degree range, then PVA has a tendency to char. And when it chars, it becomes a very hard, crusty, almost like a rock-like material, and it causes jams in the nozzle. I'm hoping that Bambu will fix this problem sometime soon with a firmware update. This is May of 2025, and they haven't fixed it yet. So what I find is that on occasion, the PVA nozzle will sometimes jam. When it does jam, the jams are catastrophic. The prints have to stop. The nozzle has to come out. It has to be, you have to put a lot of work in to try to clear those jams when they do happen, because that material hardens so hard that you just cannot get even like a purge material through. It's just rock solid. So my process for clearing those jams has been to hold the hot end in a vise with something like a forceps or a hemostat, so that it can kind of gently hold the hot end, and then hit it with a heat gun until it gets hot enough that I can force a needle through. And once I can get a needle through, then I will put the print head back into the printer and run nylon through it, ideally an abrasive nylon, something like glass-filled nylon, which does a good job of cleaning those jams out completely. And then I do a cold pull for good measure, and that tends to repair the nozzle completely. If, like me, you ever encounter a clog with PVA as a result of the nozzle overheating, and the PVA inside the hot end solidifying into concrete, please exercise caution. Please use some personal protective equipment like goggles, ideally goggles that are vapor resistant, something that is sealed all the way around your eyes. When you overheat PVA, it chemically decomposes and can become formaldehyde and some other really nasty stuff. If your eyes are exposed to the vapors, as mine once or twice were, you'll find that your eyes become completely inflamed and bloodshot. It can be quite horrifying. It's not very comfortable. Your sinuses will be completely dried out. And in general, it's probably not very good for you. So don't take it lightly. If you're going to overheat a nozzle in order to get a jam uncleared using, for example, a heat gun, please be careful. Do it in a ventilated area. Clear the gases out of the room as rapidly as you possibly can and protect yourself. Wear goggles, wear a mask. Do not take it lightly. Okay, let's see how PVA performs as a support material for TPU. It looks like the print completed without real issue. The one thing is that I can see that as the print started to complete, the priming tower has a lot of crunchiness on the top, which indicates that that PVA is approaching some sort of jam. It must have overheated. It just doesn't look quite right. Now, I'm not going to soak these in water because I don't think that it will be necessary for this demonstration. But if the PVA was to bind too strongly to either the model or to the print surface, using just a little bit of warm water will dissolve that PVA enough that it will release. And so my expectation is that we should be able to go to zero separation, and that it should cleanly separate the support from the model. But for the sake of the test, we'll start at 0.9 and work our way down in 1/10 increments to 0. So 0.9 removed extremely easily from the build plate, but it did leave the PVA behind. It looks like I will probably have to wash this plate after all. I can see that the separation between the support and first layer of the model is quite large, and so I'm expecting that this is not going to be of a particularly high quality, and I am correct. So the print quality is not ideal, but it did separate quite easily. Let's go to 0.8. 0.8 separated from the build plate entirely quite well. You can see that that came off easily, and separated from the print quite easily as well. Did not leave any residue behind, but the print, the first layer of the model looks quite bad. So let's go on to 0.7. Point 0.7 separated nicely from the build plate as well, and also very easily from the model, but the first layer looks terrible. That's 0.7. Point 0.6. 0.6 left its residue behind on the build plate. I'm noticing a pattern. Certain parts of the build plate seem to hold on to the support, the rafting, a little bit better than other parts. I'm guessing that's because of uneven heating that the H2D does to this build plate. The model separated very easily from the supports, and it doesn't look great, but not terrible. 0.5. 0.5, the raft did not separate from the plate. The supports separated very easily from the model, and it looks okay. Not perfect, but not terrible. 0.4. Again, it looks like 0.4's raft separated easily from the build plate. It looks like that all of those rafts to the left seem to be separating very easily. The support separated easily from the model, although I can see that the PVA is sticking to the model a little bit more than some of the higher separation ones. Still came off just fine, and actually that surface looks quite good. So pretty good result at 0.4. 0.3. Again, 0.3 left its raft behind. At 0.3, the model very easily separated from the supports. The quality of the first layer looks really good. There's no residue left behind. 0.2. The raft came off easily of 0.2. It stuck to the back of my glove. The model does not want to separate as easily from the support. It's attached pretty strongly. It's leaving behind quite a lot of residue, but I was able to pull it all off. So that's a very high quality print. Unsure if it's that much better than 0.3. Just a quick randomized test. Which one is 0.2 and which one is 0.3? I think they look quite similar. The answer is that 0.2 is this one, 0.3 is this one. Maybe the difference is not appreciable. Point 1. The raft came off easily on 0.1. The supports do not easily come off of the model, but they came off cleanly, and it looks pretty good. Pretty good. 0.1's looking really good. We're going to compare that to 0.3 just so that we have, some difference, because I don't think we'll be able to tell the difference between 0.1 and 0.2. There's a difference. I think that you can, tell that one is worse than the other, but it's not significant. I would be happy with either of these. This 0.1 does look quite nice, though, and it's not a lot of additional effort to remove the support material. And finally, 0 Z separation. The raft removed extremely cleanly from the build surface. That was really easy, actually, and it looks fantastic. This feels pretty good so far. All right, let's see how hard it is to remove the model. So the model's bound pretty good to the support structure, so I'm going to have to kind of peel back the support and crack it as I move around the sides. Good, and it looks like it came off. As you can see, it's a little sticky. It's like holding on to that model pretty well, but it's coming off okay. Okay, all right, I got most of it, but there is still some left behind. And so let's see if I can pull that off with just my glove. Ah, okay, yeah, came right off. I was going to say that we probably have to put that in some water, but no. In fact, this is a perfect support. It is, that's basically ideal. That's as good of a bottom surface as the top is of a top surface, basically. So yeah, 0 separation appears to be the best choice. Looks like that worked quite perfectly, and turns out PVA is a really excellent choice of a support material for TPU, especially if you have supports that are hidden, that are difficult to reach or difficult to remove. You can use this material as a support and potentially just wash it away instead of trying to reach into a place and remove it. So if you're 3D printing a basketball, for example, maybe PVA is the right answer. We'll have to try that. in lieu of simply running hot water over this plate and washing this off, because I'm in a little bit of a hurry, I'm going to use this BQ Panda Edge scraping tool. You want to be really careful when using this on PEI, because if you gouge your print surface, it'll quite easily remove the PEI from the spring steel underneath. So you want to just very gently like work yourself into the corner of the stuck material and just kind of work it up and scrape it. Yeah, that came off really easily once I got underneath it. Yep, that looks really good. Do this one. That one's a little bit more work to get off, but it came off all right. There we go. And one more. So, this PVA test was a great success. PVA does jam in the H2D. We did not have a jam in this particular print. So very successful print. I do recommend using this material for TPU supports. Okay, and now let's take a close-up look at the finish of each, starting at 0.9, 0.8, 7, 6, 5, 4, 3, 2, 1, and 0. In my opinion, 0 is the best and it's very low risk. However, I would be willing to accept the finish of 0.1 or even 0.2. 0.3 looks okay too, but I think 0.2 is probably where I would stop it. 0.2 is very, very high quality and very easy to remove the supports. Okay. All right, looks like we've got a failure. This attempt was to print BVOH as the interface and raft material for a TPU test print. And it looks like we've got some first layer adhesion issues. Looking at this quite closely, I see a couple of different indicators that might be the culprit. For one thing, it looks a little foamy, right? So even though it's been in a Ziploc bag with all the air removed, it might be a little damp. So we're going to dry this material and we're going to see if we get any better results out of that. Also, this material has a very tight printing temperature window. It goes up to 220 degrees from 190, and the print temperature on the default slicer profile from Bambu Studio is 220 degrees Celsius. I'm wondering if maybe it's a little bit hot. The BVOH, similar to PVA, does crust and kind of solidify if it's sitting in a hot nozzle if it overheats. So this very well could be scorched. Well, when I pick it off a little bit, we'll see if I get any real indicators if that is the case. And then the last thing is that I think the bed temperature was set to 55 degrees Celsius, which I think is probably fine for BVOH, but it's maybe worth experimenting with increasing that temperature a little bit. I'm going to try increasing that temperature and try it again. So let's pull off this little piece and see if this is tells us anything interesting. Okay, the BVOH that was printed it feels a little hard. It feels a little crunchy. It doesn't feel foamed, so it might not necessarily be that it is wet. So maybe that assumption might be incorrect. It feels like maybe it was just overheated coming out of that nozzle. Maybe it couldn't quite handle that temperature. All right. Still, we'll stick with the plan. We'll dry it a little bit, see if that maybe helps, although I don't expect that it will. We're going to lower the print temperature to 200, and then we're also going to increase the bed temperature and see if that helps. I managed to get a little bit too much sun today in the golf course, so I might look a little sunburned. Today, we're looking at the second attempt to support TPU using BVOH. This time we had success, and it looks quite good. One thing that I'm noticing just straight away by looking at the outcome of this print, the BVOH is, it's kind of like a white filament. And when you overcook it, when you get a little bit too warm, it starts to turn like a slightly browner color. And I'm seeing some evidence of that slightly browner color. So I think that even though the temperature on this is quite low, I think it's set to 200 degrees Celsius in the print profile, something's causing it to overcook. Maybe the bed's too hot, or maybe this is just an optical illusion and everything's fine. But looking at the priming tower, it looks like the priming tower didn't adhere that well to the PEI sheet. And I've got some crunchies on the top. I think the big difference between this attempt and the previous attempt is that I made sure to put this BVOH through the dryer for 2 solid days. Maybe that's unnecessary, but this is a super hydrophilic material, and it just wants to pull moisture out of the air. And so I kept running the dryer until the internal relative humidity dropped enough that I was satisfied, below about 20%. Maybe that's too far. Maybe it's not necessary, but I wanted to give myself the best chance that I could to get this to work since we had a failure last time, and it worked. So maybe that was the issue. Other things that might have worked, that might improve this, I would say maybe the fact that this is like looks a little bit charred makes me think that maybe this would not be an acceptable solution. But I think increasing the bed temperature slightly may have alleviated some of the problems that I had with this material sticking to the build surface. So, although that did appear to be adhered quite well, the priming tower, the corners didn't adhere at all. So I don't know, maybe this is just not a good support material for TPU, but we'll see. So we'll start at 9, we'll go down. So the BVOH is still connected to the bed, but it looks like it's partially adhered. The support disconnected from the raft very easily. So the BVOH wants to hold onto the bed more strongly than it wants to hold on to the supports. Okay, separate 0.9 from the supports. Yeah, that's separated. Oh, it actually did stick a little bit. It's not a good sign. Well, 0.9 looks terrible, and it also adhered maybe just a little bit better than it should have to the support. BVOH is a water-soluble support, very similar to PVA. So if we get anything that does over-adhere, we're going to try to dissolve that in water. Okay, 0.8. Same thing with 0.8. The support did not stick to the raft, but the raft stuck to the plate. And similarly, the BVOH interface did stick to the model pretty well, maybe a little bit better than I want it to, and that still looks terrible, obviously. So 0.8, let's do 0.7. Okay, same thing with 0.7. The support's detached from the raft held onto the plate. The support material is sticking quite strongly to the TPU. The BVOH and TPU are bonded pretty well, but it came apart. It's not a good sign, though, that it's holding on so much, even with this huge Z separation. 0.6. Oh, the raft came off with 0.6. That's nice. And the BVOH did hold on to the TPU there. Let me see if I could get it off easily. Yeah, so that's, oh, okay, I got it. It did hold on pretty tightly though, so I think we're at the place now where it's probably not a bad idea to use water to dissolve some of this BVOH going forward. Okay, 0.5. The raft came off very well, very easily. The BVOH did hold on to the model. I still got a couple little strands there. It's starting to look a little bit better at 0.5. Yeah, that's starting to look pretty good. The adhesion, the bonding between the BVOH and TPU was about the same. Not too bad. 0.4. The raft came off easily. The support separated fairly easily from the model, although we do have, oh yeah, we've got a little bit of a bonding here. We'll try dousing that in water and see how that looks. But the finish is starting to look really good, so I'm pretty happy with that. It's not perfect, got a ways to go, but yeah, that BVOH is bonded pretty tightly onto that model. So there's a little piece there that we could probably scrape off if we used a chisel, but I think probably water is a good, reasonable thing to test here. Okay, so 0.3 separated from the raft. The raft held onto the plate, and the support came off cleanly, and it looks pretty good, but we definitely have defects. So up here on the top side of this test print, we can see that it's a little bit deformed. I don't know if you can quite see that. Still not ideal. So 0.3, okay. Let's try 0.2. 0.2, the raft came right off the build plate. This all looks really good. The support separated from the model, but it left behind the BVOH interface layer on the TPU. And I've got a little bit of cleanup work to do there. Okay, with just a little bit of effort it came off. And the quality of the print is looking pretty good. That's actually really good. I'm quite happy with that. And 0.1. The raft came off the build plate. The model separated from the support easily, but the interface layer is stuck to the model. And yeah, that's not going to be easy to get off without dousing it in water. So we'll try putting that in water and see how that goes. And then finally we have the 0 Z separation. Separated easily from the build plate. The supports came off very easily. It did leave behind quite a lot of BVOH on the model, but I was able to clean up a lot of it. And this too is going to need a bath. We'll try throwing that in the water too, and we'll see how that goes. Looks pretty good though, initially. All right, we'll try throwing some of these in the water and see how it goes. Okay, so let's do some tests of BVOH in water. Oop, that one went a little bit sooner than I intended to. So I just started dropping, that was a raft, so that we can kind of get a baseline of how long this actually takes to dissolve and what the dissolution process looks like. I should probably do the same test with PVA. We didn't do it when we tested PVA. All right, so just getting it a little bit wet is starting to feel a little bit soapy and waxy. Almost instantly. Looks a little milky on my fingers. Okay, quite a lot of it has dissolved already. Let's see how long this takes. Okay, just trying to agitate it a little bit. All right, we'll go. All right. basically gone now. Not sure how long that was, maybe a minute, but it was pretty quick. There's a little bit of goo on my Allen key. It's stuck on there pretty good. All right, just wipe that off. All right, so dissolves pretty quickly. Let's then put some of our prints through that test to separate them. All right, so the first one that we'll do, looks like 0.1 has just a little bit on it. Where did I leave off? Let's see here. I'll just go through them again real quick. So 0.9 didn't have any. 8 didn't have any. 7 didn't have any. 6. Okay, 6 is a little bit stuck to it. All right, so we'll try 6. So there's 6. Let's see what that looks like after just wetting it a little bit. You can still see that there's a tiny piece of BVOH sticking out right there. It definitely feels a little bit different, a little waxy. I suppose one of the challenges with TPU, especially if it's not solid TPU, is that it's going to float. So might not be that easy to wash away supports with it under those circumstances. All right, you know what? We're going to do all the ones that have BVOH stuck to them all together. Okay, what's next? Let's see here. All right, 0.5 didn't have anything stuck to it. 0.4 had a little bit stuck to it. Here we go. Oh yeah, there's a little goo stuck to that. It's on there pretty good. Dunk that. Let that kind of wash off. Okay. Point 0.3 looks real good. Let's see here. 0.2. Nothing on 0.2. 0.1. Oh yeah, we got a little thing on 0.1. Okay. Little booger on 0.1. There's one on that side as well. Okay, there's a little bit stuck to that interface. All right, so let's go ahead and toss all that in. Actually, you know what? I'm going to invert them so that the interface side is down, fully submerged. And then we definitely had a lot stuck on 0. So let's go ahead and let 0 soak. All right, we'll give that a couple minutes. All right, let's check on some of these. Okay, so which one is this one? 0.6. 0.6, the booger's starting to get a little, like, kind of a waxiness to it. Looks, yeah, it kind of like almost smeared off, but it's still on there, so I want to let it soak a little longer. I think 0.6 was our highest one, right? Yeah, better let them all go for a while. Okay, check it in again. Let's take another little look. Okay. Start with the, what's it, 0.6? Okay, that's still visible. All right, needs more time. Gotta let it cook. With that 0 starting to look real good though, look at that. Yeah, a lot of that's dissolved off. Let's take a look at some of these other ones. Yeah, that one still's got a way to go. And 0.4, yeah, just a little booger left on 0.4. I actually don't know what this BVOH dissolves into. I am assuming that it's safe. All right, it's been a couple more minutes. Let's check in. Oh, that looks perfectly clean. That looks good. Which one was this? This is 0.4. 0.4 looking real good. We've got a little booger still left there. I'll let that one go a little longer. That's 0.6. 0.1 still got a little, oh, that's 0. 0's got a little ways left to go. Getting close there. And that's 0.1. That's still got the longest way to go. It's probably hard to see in that camera with all the glare. Oh, hold on. Yeah, that's helpful. Yeah, still got a ways to go though. Okay, let's agitate that a little bit, see where we're at. All right, so which one is this? This one is 0.6. No signs of BVOH on there that I can see. Looks good. Let's try 0. Still a little goo on 0. This is what I'm talking about. So like if these supports are completely hidden, like they're interior to the model, and your expectation is that you'll be able to wash these supports out cleanly, it'll take a little bit longer than you're expecting before all of that support material is gone. Now, this is actually quite quick. When we do the same test for PVA, I think that what we'll see is that it takes quite a lot longer for PVA to completely dissolve. At least that's been my experience thus far. Point 1 still got a little ways to go. All right, I'm getting bored. We've got 0.1. It's pretty clean. I think that that's probably acceptable. Clearly, if you wanted to dissolve it completely off, you'd have to let it go for probably another 5-10 minutes. Okay, 0, same. Yeah, still got just a little schmidge there, little bit schmoo over there. Anyway, yeah, paper towel is going to clean that up, but for hidden supports, this would have to be going for another 10 minutes or so. Let's just get that paper towel and just kind of wipe that off. Yeah, little paper towel, and that made all the difference. Starting with 0.9, looks terrible. Definitely not recommended. Next we have 0.8. Little improvement, but still quite bad. We got a cave in over here on this side. 0.7, same cave in right there. I'm wondering if this cave in is happening in the same location cardinally compared to the hot end, which might indicate that there's a well, I think it's well known that the H2D has a unusual cooling pattern that blows rather hard and down onto the model as compared to the X1 carbon, which kind of blows inward into the middle. So instead of like blowing inward to the middle, the H2D blows downward. And I think that that causes collapses like this. That's just a theory, though. We can do some experimentation and see if that's true. All right, where's 0.6? 0.6 was one of the ones that I had to clean up. 0.6. 0.6 is a pretty good looking print. It's definitely not super high quality, but the defects are much lesser. getting close to acceptable there. All right, 0.5. 0.5 is looking pretty good. I think we could still do better. In fact, if we did do better. But this wouldn't be a terrible result. Okay. Where's 0.4? 0.4 was one of the ones that we had to do a little bit of work on. Okay, 0.4 is looking really good. I'm happy with that. Little collapse right there. Not too bad though. Okay. 0.3. 0.3 has that same collapse. Okay, next is 0.2. 0.2 looks really good. We got a little bit of a collapse in that same spot, I think. But it looks like a pretty good finish. Happy with that. 0.1. So 0.1 still has a little bit of shmoo. Let's try to clean that guy up with some paper towel real quick. Maybe it needs to soak a little longer, but it's mostly clean. It does have that little collapse right there. But this is a very satisfying result. I'd be very happy with that. I think that that's very reasonable. Except that the zero separation is by far the best. It looks perfect, or as near to perfect as you can get. I'd say it doesn't look quite as good as the test that we did with the PVA. I'll have to go back and check the footage. But I think the PVA does win, but just barely. I mean, I think that this is quite a good result. I think between this, the PLA, the PVA, I think that all of those are very decent support materials. PCTG is also fine. So yes, I would say BVOH is a very reasonable choice, especially if you need dissolvable supports. It's a little bit of a pain in the ass to work with. And if you are going to work with it, zero Z separation is absolutely acceptable. Separates pretty easily, cleans up pretty easily as a result of dousing in water. So I can confidently recommend using zero separation with BVOH. It does adhere to the model. That's okay though, because it will wash right off. Okay, great test result. This test batch is TPU supported by PLA, using PLA as a raft. One thing to note that's interesting that we'll see over and over again throughout these tests is that the models which were printed with a top Z distance between the support and the model of 0 use an entirely different tree support structure than the other models which are printed with the separation between the support and the model itself. That's because Bambu Studio, which is the slicer that I'm using, takes some special steps and considers the support to be a part of the model if there's a 0 distance separation. So each of these tests are prints of the TPU with PLA as the interface between the TPU support and the TPU model, with different distances between the support and the model, starting with 0 and going up in 0.1 increments. And so what we're going to do is break them apart. First of all, take them off of the plate and see how hard they are to remove. I assume that they are going to be quite easy because of the rafting that we've done using PLA as the raft. And then we're going to see how difficult it is to separate the models from the supports, starting with the easiest one, which is going to be 0.9 millimeters separation between the support and the model. So we'll remove that one first. Okay, came off extremely easily. It has left behind, it looks like TPU on the plate, even though I selected PLA as the raft interface material. So I may have to scrape that a little bit. As expected, this is going to come apart quite easily. Yeah, it does come apart very easily. The surface is terrible, so 0.9 is probably too much separation between the model and the support. Okay, let's try 0.8. 0.8 separated easily from the base as well. Also left behind the raft, which looks like it's made out of TPU, so maybe the slicer setting was either incorrect or there's a bug in it. Okay, and then separating the model from the support, came apart extremely easily. The surface, again, is quite bad, so this is probably also not a great choice for separation. Let's do 0.7. Again, separated very easily. Noticeable improvement compared to the 0.8 or 0.9. Here's 0.9 as a comparison. Okay. Let's try 0.6. 0.6 separated entirely from the build surface very easily. 0.6 separated very easily from the model, but the finish is also still not acceptable, quite bad. We're getting there. 0.5. The raft of 0.5 was left behind. The model separated easily from the support with 0.5 millimeters separation. The finish looks pretty good. We're getting to a place of acceptable finish. It's still not quite there. I would still reject this and say that this is probably, we could do better than this. Okay, 0.4. 0.4 separated entirely from the bed, took the raft with it, which is nice. The model separated easily from the PLA support. It appears as though the, it separated very easily, and actually the surface finish looks quite good on this one. That appears to be a pretty acceptable finish. We're getting into the realm of what I would consider to be okay. But 0.3 also separated very easily. The PLA in this case is gray, which is a very similar color to the gray used on the TPU. So it's kind of hard to tell what is the TPU and what is the PLA, but it looks to me like the PLA separated from the model entirely. There was no PLA residue left behind on this particular model. So far, 0.3 is looking really good. Let's see how 0.2 looks. 0.2 separated easily from the base, from the plate rather. The support is attached a little bit more strongly to the model. Oh, but that finish looks just fantastic. And it's separated very easily as far as supports go. 0.2 would be a good choice. Let's see how 0.1 is. Point 0.1 separated easily from the build plate. The supports separated easily from the model. Oh, and that just looks fantastic. We're getting into a really high quality finish at this point. That was point 1. And then finally, we have zero separation. Zero separation looks quite a lot different from the others. As you can see, the tree supports are not at all the same. The base in this case, the raft, is very clearly PLA. So that did work correctly, as I expected. However, anyway, separating this is a little bit more work. I have to quite put a little bit of effort into peeling it, but the soft nature of the TPU in the tree support makes it very easy to bend away and allows for the PLA interface to come along with the model, and that is just exquisite. That's as good as it gets. So that's a perfect interface from the TPU with PLA as the interface material for tree supports with a zero top Z distance between the model and the supports. So that is definitely the recommendation for this combination of materials. This is an extremely high quality, very satisfying result. If you ever print an organic shape out of TPU and you're supporting it using PLA, but you have some difficulty removing the supports, like I just did with this little guy. This is Vario Shore TPU, and it's very squishy. The PLA bonded a little bit strongly to this model, especially in some of like the curved and odd-shaped supported areas. Well, what I did was I threw it in the freezer, and the PLA shrank enough and became brittle enough that it separated basically right away, came straight off. So if you ever have a TPU PLA bond that's a little bit too tight for your liking, throw it in the freezer. It'll come right off. And the other side of this, which is that if you actually genuinely want your PLA to be a part of your model with a TPU component, then it's a really good idea that you don't get that thing too cold, because your components will come apart basically immediately. So living hinges with TPU with a PLA model, might not want to get those very cold. Just a heads up. So we're using PCTG as the raft material that will separate the build plate from the TPU supports, and then an interface material that separates the TPU support from the TPU model. A single layer or 2 layers of PCTG will be placed, which I expect will be an excellent interface material. It should be quite similar to PLA. I imagine that it will adhere just a little bit better to the TPU, which might be a disadvantage, right? Because it may be the case that it adheres too well. So my expectation is that it will probably be a good support material, but maybe not the best. But I suppose we'll see. PCTG is a slightly more flexible material than PLA is, and so my expectation is that as a result of that flexibility, it may adhere a little bit better. Okay, our test print was very successful. Everything looks perfect. Everything is adhered well to the bed, and it looks good. So let's start with 0.9. 0.9 came off the bed perfectly. We have a good raft separation from our build surface, which is as expected. It is, after all, PCTG being printed on a PEI sheet that is textured. Okay, looking at it from the side, I can see that the separation is quite high between the interface layer and the model, and it doesn't look like it's particularly high quality. The supports peeled away very easily from the model, and the supports came off quite cleanly. They look great. The model, however, does not look great. There's no PCTG residue on this test print. However, the first layer that's printed on top of the PCTG looks extremely low quality. So this is probably going to be a rejection. Next is 0.8 separation. 0.8 was removed from the print surface very easily. The supports were easily removed from the model. The supports look great, they're intact. The model does look very bad though. That's pretty unacceptable. Let's move on. The next is 0.7. The model wanted to detach from the supports more easily than the raft wanted to detach from the print surface. It's already partially separated, and as I pull it apart, yeah, that support structure looks really good. It's entirely intact, no complaints there. However, again, the first layer from this model does not look very good. Again, another rejection. Point 0.6 is our next test. 0.6 did not want to detach from the build surface as easily. It's also a little bit more work to separate from the model, but not too bad. They did come apart quite easily and cleanly. This is starting to look okay, right? We're getting close now. This actually looks pretty good, and it appears as though PCTG might be an okay choice as a support material at 0.6. Next is 0.5. 0.5 separated from the model from the supports more easily than the supports from the print bed. It's already partially torn apart. And once I remove the model from the supports, I can see that the supports came off quite cleanly. The model also looks quite clean. We're getting good. This is looking a lot better. Noticeable improvement, still quite bad, but not as bad as the earlier tests. Next is 0.4. 0.4 came off the print bed pretty easily, although it was attached a little bit on this side, a little bit better than the other side. A little bit more difficult to remove from the model, but again, quite effortless. This is still quite acceptable. The PCTG stuck to the model a little bit more in this print than it did in the previous ones, but the finish on the first layer looks quite good. This is quite good. It's almost perfect, although it could certainly use just a little bit of cleanup. It's looking quite good now. Point 0.3. I crushed 0.3 pulling it off the print bed. It was stuck on there a little bit more than some of the other prints. Separating it from the model, it's stuck on there pretty good. Okay, no, it came off nice and easy. This is still an acceptable separation. Supports came off pretty cleanly. The first layer looks about the same as 0.4. Next test is 0.2. 0.2 came off the build plate quite cleanly. It's a little bit more difficult to separate from the model. It's adhered quite well to the model, and I have to work a little bit more to get it off. As you can see, it's just starting to bond to the model kind of semi-permanently, and now we've left a tiny remnant behind. Now that will be easy for us to clean up, but the first layer looks really great. So I think this is probably worth it. This might be the choice, the sweet spot of good layer adhesion and bonding versus good first layer of the model. Let's see how we could do with point one. Point one is bonded quite well to the build plate, but it did come off cleanly. Point one's interface supports are bonded extremely well to the model. It's starting to leave behind remnants of the PCTG on the model's first layer. Okay, not bad. So again, we've got here maybe one small strand on the interface layer that has bonded well to the TPU. That might be a little bit difficult to clean up without marring our model. This might have gone too far. Now, that said, the surface looks just fantastic. It's really quite clean. I'd be very happy with that if I could definitely clean this up. We'll come back and try to clean that up and see how that looks. Okay, last test is zero separation. So this is no separation in layers between the interface and the model itself. Oh, comes off the build plate really well. I much prefer this algorithm that Bambu uses than the other one. It really is quite well designed. You can see that it has a kind of like cross pattern in the bottom because the supports are divided into 4 parts, unlike the supports from the others, which are kind of concentric circles around, more randomized tree supports. This PCTG is difficult to remove from the model. It is coming apart though. Okay, there we go. Yep, if by bending the tree supports a little bit, the interface layer starts to crack, and as it cracks, it separates a little bit more easily. Getting a little bit of bonding. Okay, that came off finally. The tree supports were damaged quite a lot in the separation. Some layer, it looks like it's a multi-layer support, and one layer just came off completely. It broke apart, so you can see that this was bonded quite well, and it left behind quite a lot of residue of the PCTG on the TPU print. This again might be something that we could clean up, so we're going to try to see if we can clean that up successfully. And if so, then this is definitely, I mean, the finish on this for the parts that are not bonded to PCTG just looks fantastic. So let's see if we could clean this up a little bit. For model finishing and cleanup jobs like this, I typically like to use a couple of different tools. I have a set of dental picks, which are quite useful. But in this case, since we're working with TPU, we can be a little bit rougher and not worry about scraping or damaging the material as we clean it up quite as much. So I'm going to use really 2 of my favorite tools. This is a kind of chisel pick. There's a couple of different tips that I have for this. I'm using one of the sharper ones right now. And these pointy pliers, which are, you know, whatever cheap Amazon pliers that you can get for practically nothing. Maybe both won't be necessary, but we'll see. Okay, so we're going to start with trying to clean up this. This is the 0.2 model. There's just one tiny little defect here. Let's see if we can get that out. Okay, yeah, that removed perfectly and was quite easy. And we've got a nice finish here. This looks great. Point 1 has a slightly larger permanent adherence and defect, and one more on this side. So we'll use the chisel to try to chisel those off. Yep, that popped off quite easily. Yeah. That last piece did not come off quite so easily, and I did damage the surface just a slight amount. I'm not sure if you can quite see that. It's not quite as perfect as it was. There's a small divot right there. Same on this side. So maybe this isn't the best tool for this. Maybe the dental tool would have been a better choice. I did remove the support. It is no longer bonded, but the finish isn't quite as good as it was. This is still quite acceptable. I'm very happy with this. Okay. Last one. This is the zero support. We'll start with removing the tiny bonded part first, and then we'll move on to this bigger part, and then we'll do that one. Okay. that came off quite easily. One danger about using a tool like this, it's obviously very sharp and I'm pushing it toward my finger. You could very easily catch yourself. I've done it a couple of times. It's not a good time. Just be careful. Okay, we'll get to the bigger piece here. So I'm going to kind of work it from the side. Separating a little bit. Oh, it's quite on there. Quite on there. Try to get it from the other side. There we go. There we go. That came off really well, but I feel like it was maybe just a little bit lucky. It didn't want to come off at first. I had to work on it pretty hard, and I managed to get it off without damaging the surface. So I would say that if I was working on a very large print that required supports, I would be hesitant to use zero separation, because it very easily could be permanently bonded, especially if that support's in a difficult place to reach. You might not be able to get that off without leaving behind a residue or damaging the part. So depending on how important surface finish is to you, if you're looking for perfect surface finish, this might not be the best choice. Let's get that last little piece off. Yeah, that's bonded quite well. Yeah, that's definitely in there pretty good. That's in there really good. Yeah. All right, I've damaged the surface just slightly. Not too bad, but I did get the support off. It'll be difficult, I think, to see, but there is definitely a new divot here that I've created with this pick. Otherwise, it looks pretty good. I would say that that's, I mean, look, there's no guarantee you're going to get this kind of result cleaning it up quite that way, but as far as results go, this is a pretty good one. I would say if you're willing to take the risk, this is the best. But if you want to play it safe, this is the 0.1 millimeter separation. Yeah, the quality is quite noticeably degraded, but the removal of the bonded support, I would say, was easy enough that I would be willing to take this risk. As long as I could hide the support marring, then I would be quite happy with it. Yeah, I would probably use this as my default setting going forward. This if I needed it to be safe. Okay, let's get a close-up of the finishes, starting with 0.9 to 0.8, 0.7, 0.6, 0.5, 0.4, 0.3, 2, 1, and 0. And so you can see them all together. This test is Polymaker Support PLA as an interface material for a TPU model and support print. My expectation is that this is going to work about as well as PLA, which is to say that it should work quite well. So let's just dive right in. We'll start at 0.9 and work our way down to 0 in 0.1 increments. So let's start with 0.9. 0.9 removed from the base but left the raft behind. The separation between the model and the support is significant, and the quality is quite bad. Maybe not as bad as some of the others at 0.9. Next is 0.8. 0.8 left its raft behind as well. It appears as though the raft does not stick particularly well to the TPU. that means that this support material doesn't stick to TPU really at all. It prefers to stick to the plate, which, okay, that's reasonable. Doesn't make it a bad support material at all. It's separated very easily. And the quality is quite bad, but not as bad as some other 0.8s that we've seen. Next is 0.7. 0.7 left its raft behind as well. .7 separated easily from the supports, and the quality is slightly improved over 0.8. Next is 0.6. 0.6 removed easily from the base, but left its raft behind as well. The 0.6 supports came off very easily. The quality of the surface of the first layer of the TPU is pretty good, not bad. Next is 0.5. 0.5 also left its raft behind. The model's easily separated, and the quality is pretty good. Marked improvement. Next is 0.4. 0.4 left its raft behind. The supports are stuck a little bit to the model. The supports are actually quite stuck to the model. This required a little bit of effort to remove. We have some interface layers permanently bonded to the model. Oh, nope, they came apart with just a little bit of tugging. But we still have, a little bit of remnants here. So at 0.4, we're starting to leave little pieces of the support interface bonded permanently to the model. We could probably get this off with our chisel tool. We'll come back for that. Next is 0.3. 0.3 also left its raft behind. Point 3 is also quite difficult to remove from the model. It appears to be leaving some interface material bonded to the model. I got most of it off. There's just a little bit left that needs to be addressed with some finishing. 0.3 was easier to remove than 0.4. 0.2. 0.2 left its raft behind. 0.2 is very difficult to remove from the model. It is quite well adhered. Okay, after a little bit of work, I was able to get most of it off, but we do have some work to do to clean that interface up a little bit. So far, it appears that 0.4 might be the best choice without having to do any additional post-processing. But we'll take a closer look afterward. This post-processing isn't so bad, but this doesn't appear to be the best material to support TPU with. 0.1. 0.1 pulled some of its raft off, but not much. The model is quite difficult to separate from the support. I am making some progress on it though. Yep, and it's left behind a little bit of a mess for us to clean up. Definitely not the kind of finish that I would want for a print that had supports in a large area or in difficult to reach places. This would be a lot of work. Finally, 0 millimeter separation. The raft came off mostly with the model. In order to separate this, I have to kind of squish the support, but it's a little bit easier to do than it is with the other tree supports. It's left behind the entire interface layer. There's actually one interface layer on each side. So the two interface layers didn't stick to each other, but both stuck to the TPU quite well. This is going to be a lot of work to clean up. We'll give that a try. To clean up the raft layers, I'm going to use my scraper tool. And it appears to be coming off quite easily. So the rafts aren't particularly well bonded to the print surface. It's just that they did not bond very well to the tree supports at all. So easy to remove, but did not prefer the tree supports. This one's a little bit more work to remove. There we go. It has the feeling of an exceptionally well bonded PLA to the print surface. Sometimes on these PEI sheets, if you have PLA that bonds a little bit too well to the print surface, hitting it with some cold air, throwing this in the freezer, or using duster, will sometimes cause the print surface around the print to shrink enough that it releases the print. But that's not necessary for this. This will come right off. Almost done. That one came off nicely. Last one. Okay. Okay, here's 0.9. Quality of that print, the interface is not great. Next is 0.8. A little bit better. 0.7. 0.6. 0.5. 0.4. Starting to look pretty good. 0.4 has a couple of little remnants on it. Let's try to clean those up. Okay. This is quite bonded to the print. This PLA support is, yeah, I've damaged the surface just a little bit. Not too bad, but I did get it off. Okay, we've got one more. That is also quite bonded on there. I think already at 0.4, this is a bit of a nuisance, and I would be unhappy attempting to clean this up, especially on a large print, or if this support material was difficult to reach. Okay, that looks like it has freed. There we go. And I've got a little guy right there. Yeah, that little guy is pretty good on there. Quite well bonded. So I think the lesson here is that the Polymaker PLA support sticks quite well to TPU. Probably not a great choice as a support material. 0.3 actually came off a little bit cleaner than 0.4. We only have one little spot to remove. My guess is that if we were to run this test a second time, that might not be the case. 0.2's left us a little bit of work to do. Let's try to get some of this off. That's coming off okay. That's bonded pretty well. Yeah, okay. Yeah, that came off all right. How about this one? Ooh, not easy to get off. Not easy. Okay, I've now damaged the surface of the print. Yeah, I got it off, but I did damage the surface a little bit. One more. Yeah, quite difficult to remove. Quite hard. Yeah, I got it off, but I did damage the surface a little bit on that side too. And then, okay, that one also came off, but it brought a little bit of TPU with it. So this 0.2, I mean, it looks quite good, despite that little bit of damage that I did to it, but it was a lot of work to clean up. Probably not my recommendation. 0.1, quite well bonded here. Okay. Let's try to get as much of this cleaned up as possible. All right, get in there. Okay, that came off a little bit of a pop. Okay, that is also coming off, but yeah, this is bonded well enough that I'm going to have a pretty big gouge on this model now. Oh yeah, yeah, that is. All right, well, now you can see that there's a little flaw here. I don't know if that's showing up that well on the camera, but it is visible to me. Okay. Okay, that came off pretty easy. All right. Oh, those are, oh, that's really well on there. This is a little bit of a nuisance. Pulling on this material, this Polymaker PLA Support material, it is a little bit rubbery. It has a little bit of a tensile, ductility to it. It can be drawn a little bit. I'm wondering if it's actually a kind of TPU or a flex PLA, and maybe that's why it's such a good support material for PLA. But for TPU, I don't love it. Don't love it. Yeah, really, really difficult to remove this at this point. I would say that this is a fail as far as I'm concerned. I'm unhappy with this. I would not want to do this on a large print. Oh, got that off. And that looks okay. Yeah, so you can see here that I've done a little bit of damage to the model right here. This might have to be a reprint if it was something that that I was actually going to use. So 0.1 I would say is a fail. Not happy with that. And finally, zero separation. Let's see if I can do anything with this. This might not be worth the trouble. Yep. Yeah, forget it. Forget it. This is hours of work just to do this tiny little sample, and I don't think you're going to make much progress on it. What will be left behind is going to be a quite scarred and marred model. Well, actually, what's left behind looks pretty good. It's just a ton of work. This is very difficult, very arduous. Looks like I'm getting it off without doing too much damage to the model underneath, but this is like surgery, you know? No one wants to do this. Yeah, that is bonded just entirely too well, but the finish looks pretty good. So in a pinch, yeah, you could probably use this Polymaker support for PLA material to support TPU. If you were going to do it, I would say you probably want to pick something between 0.2 and 0.4 millimeters. My recommendation is probably to stick with 0.4 because anything lower than that, it's a little risky that you will be able to actually remove the supports. And this is the finish that you're going to get from 0.4, which is okay, but nowhere near as good as we can get with some of the other materials. All right, I've got something a little unexpected today. This is TPU supported by Polymaker's nylon support material. as the interface. I was not expecting this to work. I was expecting that this would not adhere to the build plate because of the obvious difference between the temperature requirements between these materials. But what I was surprised to see was that the Bambu H2D slicer, Bambu Studio slicer, as a part of its slicing plan, decided to heat the chamber temperature in order to compensate for this support material. I didn't expect it to do that. So the result is that the TPU did string a little bit because the chamber was quite hot. And it looks like the surface finish of the TPU is a little bit warped, you know, and it's not perfect. It's got a little bit of almost like an over extrusion look to it, a little melty. But I mean, this stuff all cleans up pretty easily, and so the fact that the print succeeded with just this little bit of, you know, schmutz, it's not so bad. So far, nothing jumps out to me as being alarming, but I would say that the print quality is just a little bit down, I believe, probably because the temperature of the chamber was just a little bit too high for printing with TPU. But nevertheless, let's see how it works. So we're going to start with 0.9 and work our way down in 0.1 increments. Our first test is 0.9 millimeter separation between the interface layer and the model using Polymaker's nylon support material. Okay, so the model separated easily from the support, but actually not that easily. Even at 0.9, it was still stuck on there pretty well, and the support and raft are pretty well adhered to this build plate. This might not have been a great choice to attempt to build this nylon support material as a raft on PEI. It appears to have bonded quite well. The result of separating the model from the supports is quite bad as well, even though it adhered quite strongly to this model. So this does not bode well. 0.9, already not looking so good. All right, let's try 0.8. Okay, 0.8, the support came loose from the raft. The raft is pretty well bonded to the PEI plate. Let's try now to separate the support from the model. Came apart pretty easily. It is bonded a little bit, not too bad though. Finish is about as expected, not quite good. 0.8 millimeters, not great. Please note that all these tests are being done on the Bambu H2D with a 0.4 millimeter nozzle. The results might be quite different if we were to use, for example, a 0.6 nozzle, or 0.2 for that matter. Okay, next is 0.7. I'm also noticing that my markers indicating the Z separation on these models is a little bit harder to read in this TPU, again, probably because of the high chamber temperature, causing it to kind of melt around a little bit. Okay, the raft was left behind on the build plate. The model separates fairly easily from the supports. Little bit of bonding, not great. And the finish is not great either. Okay, 0.7. This is not looking good. 0.6. Okay, 0.6 is on there pretty good. Okay, 0.6 did separate from the raft. The raft is bonded onto the PEI quite strongly. Let's see if I can separate the model. Okay, the model did come off. It felt like squishing the TPU supports really made all the difference here. A little bit of bonding, it did come loose. The finish is still terrible, and we have all this oozing and stringing that we're seeing on the model itself. Finish is okay, not great. Improved from 0.7, but still not very good. Okay, now we've got 0.6. Left the raft behind. The model did separate from the support material pretty well. A little bit of bonding again, not more bonding than I think the previous test. Finish looks so-so. Definitely an improvement, but we know that we can do a lot better than that. Okay, 0.4. Oh, raft came loose this time. That's actually very encouraging. That makes me think that when I come back to clean these rafts up, it's probably going to come loose a little bit better than I expected. Okay. Separating the model from the supports. It's a little bit of work here. Yeah, it's bonded pretty well, but it comes off all in one piece, and actually that finish looks pretty good. I'm pretty happy with that. 0.4 is looking okay. I think that's probably about as good as it's going to get. I'm guessing 0.3 is going to start to have some permanent bonding between the interface and the model. Here we go. Let's find out if I'm right. 0.3. 0.3 is bonded very strongly to the build surface. Okay, it came off, but it left the raft behind. Okay, yeah, it's separated about the same actually, and the finish looks just a little bit better. So it is improved. I was wrong. 0.3 still looking like a little bit of an improvement. It does pull away. It cleaned up easily, no problem. Let's try 0.2. Oh, 0.2 released easily from the build plate. Very unexpected. Again, I'm suspecting that this has something to do with the heating pattern of the build plate on the H2D. Some inconsistencies around heating. But separating the model from the support is a little bit of work now. Okay, once I crush the tree support, it starts to come off a little bit easier, but it's still some work. All right, I got it. There we go. Okay, it's bonded pretty well there, but a little, some pretty significant effort. That's pretty significant. Okay, that came loose, but with a little bit of a pop. So now we're starting to get into the realm of, this is at 0.2, so we got really far, actually. I think at 0.2, we're now running the risk of a complicated model being quite difficult to remove the supports. I would say it's probably not in our best interest to do a real model with 0.2 millimeter separation between the support and interface. Finish looks pretty good, but this is starting to get into the realm of risky and very difficult to clean up. Let's see how 0.1 works, if there's any prayer of separating this. Okay, that's really on the build plate quite good. Okay. Came off and it brought the raft with it, which is nice. Okay. Okay. Might have to remove my gloves in order to get this off. All right. Okay. Yeah, this is definitely a fail in my opinion. This is bonded too strongly. It is coming off, but I'm working pretty hard for it. I was able to do it with my gloves on though, so not a total fail. This is a possibility if you have a simple, straightforward model with a very flat, easy to access support, then you can get a pretty good result. You know, that's a pretty nice finish. Not easy to remove this, and the finish is only, you know, approximately as good as some of the other materials that we've had that are much easier to remove. But we have one left, and that's the 0 millimeter separation. Ooh, that came off beautifully. Nice job, Bambu. This is a really nice feature. These 0 millimeter separation supports, they work so well. So impressive. All right, let's see if we can get this guy to separate. Okay. Oh, it actually came loose. It came loose. Holy moly, it actually came loose. Look at that. And the surface looks really good. It looks really good. The model has some oozing and stringing. It has a little bit of warping as a result of being overheated. But that is the best result. It's a better result than 0.1, 0.2, or 0.3, even better than 0.4. It was easier to separate. The surface finish looks just great. I've got a little bit of an elephant's foot. I don't know if you'll be able to detect that on the camera. But yeah, there's the base of this is squishing out just a little bit, and that's probably the result of overheating as well. Okay. Let's see how hard it is to remove these rafts from this support, from the PEI plate. That came right off. That's nice. Okay, start with this one here. Oh, that's on there pretty good. Yeah, that's on there pretty good. I wouldn't recommend this. Okay, yeah. Once you get it going, it comes off nice and easy, but getting that first little corner up is a little bit of work. Let's see if I can do it from another angle so you guys can see what I'm doing. Yeah, that is quite difficult. I can start to see that it separates just a little bit. As soon as it does, I can get underneath it and pull it right off. But getting that first little corner started is a little bit of work. You can see that there's a little bit of a bubbled up side over here, so I'm going to use that as a starting point. Yeah, there we go. That came off nice and easy. Good. All right, do this one. Oof. Oof. Try to pick another side, maybe something that has a little more leverage. Oh, I don't like that. Don't like that. Got it, but that was some pretty difficult work there. Okay. Okay, that one came off nice and easy. And one more. Okay, last one. There we go. Better not block the view. Oh, shit. There we go. All right, that came off great. Okay, cool. All right, so what's the lesson here? Is there a lesson? Is there anything to learn from this? I think probably the lesson, in my opinion, is that this is a material that you could potentially use in a pinch. If you have nylon support material made by Polymaker just kind of lying around, you need something to support TPU, you could do it. You're going to need to heat the chamber. You're going to need to have your build surface a little bit warmer than I think you typically would for printing with TPU. You're going to have some warping on the TPU. The interface material is going to bond extremely well to the TPU, but it is removable, it is cleanable, and the end result is acceptable and actually quite good. At 0 millimeters of separation, looks quite good, maybe even as good as some of the other, higher, better choices for interface support material. However, the other concessions that you have to make in order to use this material would make it not my first choice. Let's start with 0.9. Maybe zoom in a little bit more. 0.9. Not looking so hot. 0.8. 0.7. Bring all these into frame together. 0.6. 0.5. 0.4. Pretty big jump in quality. 0.3, 2, 1. Let's zoom out just a little bit here. Yeah, there we go. 1. And 0. 0 is clearly our winner here. Let's see if I can align this in a way that you can see them all together. There we go. Okay, so we have an unlikely scenario here. This is TPU being supported by nylon by Bambu Lab. The print didn't totally succeed. We have at least one failure here. It actually detached from the plate, and it looks like maybe some of the rafts made out of nylon did not adhere particularly well to this build surface. I probably should have put down some nanopolymer adhesive in order to make sure that this is going to stick well to the PEI sheet. Also, this PEI sheet did not get hot enough to adhere to nylon well, so there's no real surprise there that it didn't hold on particularly well. But is it a good material for an interface between TPU models and TPU supports? Well, I'm not sure. So yeah, we'll start with 0.9. I'll work our way down as we do. Okay, 0.9. 0.9 detached from the build plate quite easily. I think probably none of these are particularly strongly adhered to the build plate. Looking at it, it looks like the interface has quite a large Z distance between the Z distance and the model at 0.9, and I'm guessing it's probably not a particularly high quality. And actually separated with just a little bit of work here. It looks like the TPU wants to hold on to the nylon a little bit better than I expected, and in fact, I can see that there are some remnants of the nylon on the TPU on the bottom from the raft. So 0.9 already is holding on to that nylon just a little bit too well. Might not be a great choice. Let's try 0.8. 0.8 released from the build plate very easily. Raft completely detached. The model separated pretty easily from the support, and it looks quite bad, but at 0.8 that's not that much of a surprise. Okay. Okay, on to 0.7. 0.7 also released very easily. Took the raft with it. TPU model separated from the TPU support and the nylon interface quite easily. It does not look like there's any remnants of the nylon stuck to the TPU there. Point 6. 0.6 was barely attached to the plate. A little bit of effort to separate the model from the interface layer, although it does not look like there are any remnants of the nylon stuck to the TPU model. One thing of note is that this nylon material, using it as an interface, caused the bamboo slicer to increase the temperature of the chamber quite dramatically, and I think it also increased the temperature of the heat bed more than it normally would. And there's definitely some evidence of that. There's the stringing that we've seen from some other higher temperature support materials, and also some elephant footing and just a little bit of warping and deformation on the tops of the models. So it looks like this heat difference has caused the models themselves to lose some of their quality. So probably not a great choice to choose a support material that requires a temperature that's significantly higher than the model material. Okay. So 0.5 separated easily from the print surface, but was attached to 0.2 slightly. The model separated very easily from the interface layer, and it looks like it came off cleanly. The quality of that is not very high, but not bad, not bad. I'm starting to get to a place where it might be okay. All right, I'll just put 0.2 to the side for now. This is 0.4. 0.4 came off very easily. The nylon is bonded quite strongly to the TPU model, but it did come off cleanly after just a little bit of bending. So that looks okay. That first layer actually looks pretty good. Okay. Next is 0.3. All right, 0.3 came off pretty easily. And the interface separated very easily from the model. The quality of that first layer actually looks pretty good, not bad. Okay, 0.2 was the one that didn't attach to the plate. It actually failed. And it is very well adhered to the model. All right, I'm having a little bit of difficulty separating the model from the interface layer. Okay, but I did get it. And when I got it, it actually came off pretty well, and that finish is looking pretty good. I could see just a few remnants, permanent bonding of some of that nylon to that TPU. Just little hints of it. We could try to clean that up. We'll take the pick to that and see if we can get that off. Okay, 0.1. 0.1 was barely adhered to the print surface. Not a good sign if you're printing a large model. You do want more adhesion than that, but yeah, and separating the model from the interface layer is some real work here. I think that now we're in the realm of risk. Did all come off pretty cleanly. I see one little dot that I want to try to, pick off. But that came off pretty well, and that first layer is looking pretty good. Not bad. That was 0.1. And the final model is the 0 separation, which separated very easily from the build plate, barely was holding on at all. It's extremely difficult to separate. But now that I've started it, it's coming off very easily, and it actually looks pretty good. It came apart pretty easily and did not leave behind any remnants on the model. Okay. So what's the takeaway from using nylon as an interface material for supporting TPU? Well, I would say that it's not a great choice. If you need to use it, it'll work. Unfortunately, though, you'll have to increase the temperature of your chamber so much that your model can be damaged. It might warp. It might be, it might elephant foot. You might lose some details. And the nylon doesn't stick particularly well to PEI unless you use some sort of adhesive. And so I think you run a higher risk of potentially having your model fail because it may detach from your print surface. So for those reasons, I would say it's not a great choice for a support material for TPU. It's also very expensive, so why would you do this? But if all you had on hand was nylon, it'll work for TPU. Okay. 0.9 doesn't look so good. There is one little dot of nylon stuck to the bottom from the raft. Let's see if I can get that off or how well that's bonded. Ooh, it's bonded on there pretty good. But once you get it started, then it comes off pretty easily. I would say that I probably damaged the surface of this trying to pick that off, but it's very difficult to tell. Okay, 0.8 doesn't need any cleanup, but it also is not particularly high quality. That's not looking so good. It does have quite a bad finish on it. It's also quite warped. It's got a lot of stringing, so yeah, not a great print. 0.7. 0.7 doesn't need any cleanup. Not of a particularly high quality. I'd say probably not the right choice. 0.6 doesn't need any cleanup. And it also doesn't look very good. 0.5 does not need any cleanup. It does not look particularly good. It looks a lot better than 0.9 did. I can hear a little ding of nylon there, but can't quite see it, so looks like it's all right. 0.4 is starting to look okay. Doesn't require any finishing, although we do have this oozing and stringing going on the side. Probably because of the temperature of the chamber or the difference in temperature between the two filaments. Okay, 0.3. No cleanup necessary for 0.3. 0.3 is looking pretty good. Uh, 0.2 separated from the build plate. And it looks like it came off clean from the nylon. The finish looks really good on the bottom. It's unfortunate that it came off the build plate, though. 0.1 has a couple little nylon remnants. Let's see if we could pick that off. Yeah, that came off pretty easily. Not a lot of risk in trying to clean that up. It doesn't look like you're going to damage your model, and it came off pretty easily. So 0.1 seems fine. And then 0. Yeah, 0 looks pretty good. Finish looks good. Nothing to do to clean it up. Lots of stringing and oozing like some of the others. So, I mean, it seems to me like 0 separation is probably the best choice if you're going to use nylon to support TPU. But it's probably not the best material if you have to pick one. This test is Bambu's new PLA support, supporting TPU as an interface layer. My hopes are pretty high for this material. I think Bambu's had a little bit of time to work on this and try to dial it in. I really dislike their old PLA support. But, you know, I have heard that this is a better material. I have not tested with it previously. This is my very first experience with it. It's not intended for TPU. It probably won't work brilliantly with TPU, but my hopes are high. I am hoping very much that this material works really well with at least PLA, as it should say, or as it says so on the box. But I think that there's a good chance that it will work with TPU as well. So let's just get into it. So 0.9. Okay, so the raft and supports stuck to the build plate quite strongly, but did not stick to the model, and so separated quite easily. So that is 0.9. Surface finish is not very good, but that's not surprising. Let's see if we can get this off easily. Okay, the support came off easily, but the raft stayed. Let's see how hard that raft is on there. Pretty good. We might have to do a little bit of work to clean that up. Okay, 0.8. Okay, the raft stuck to the build plate still. The support came off this time. Let's see how hard that is to separate from the model. Quite easy to separate from the model, although got a little snag there. Yep, looks like we've got a little bit of bonding already, and we've got two little dots of support material bonded to the TPU model, which does not bode well. That's probably not a great foreshadowing here. All right, let's try 0.7. Okay, 0.7 separated from the raft. The raft stayed on the build plate. The model separated quite easily from the support, although there seems to be some sort of failure here, and for whatever reason part of the model didn't adhere internally. I wonder if that's a side effect of using this as a support material or the distance in the Z separation. Regardless, we got a little bond there. I'll try to come back and clean that up and see if that's on there really well. Okay, 0.6. The raft came off this time. 0.6 separated easily from the model. Oh, got a little artifact left behind. Finish still looks pretty bad, but a little improvement. We still have collapsing on the side of that model. Okay, let's do 0.5. 0.5 left its raft behind. The model separated easily from the support and cleanly, and the finish looks pretty good. We've got a couple little defects, but not too bad. This is starting to look pretty nice. Okay. 0.4. 0.4 left the raft behind. The support separated easily from the model. Not that easily. And actually starting to leave some remnants behind. A couple little bonding issues. And it also looks like I've got the same failure here that I had on the, what was that one? 0.6 or so, where the model is internally failing, separating. This appears to be a side effect of this particular support material. Very weird, very weird. Uncertain why that would happen. 0.3. 0.3, the raft separated from the build plate. The model separated from the supports, but the interface layer is quite strongly bonded onto the model itself. And we'll have to try to come back and see if we could clean that up, but I don't think that we're going to have much luck with it. We might already be screwed. In which case, it seems like maybe 0.4 is about as good as you can get with this, but we'll see if we get any surprises. All right, 0.2. 0.2 left its raft behind. Okay, 0.2 actually looks a little bit better than 0.3, but it did strongly bond the interface layer. Ooh, okay, that actually came off a little bit easier. It did bond the interface layer quite strongly to the model, but I got most of it off pretty easily. And it too has this little weird separation in the model itself, some sort of failure. Very odd, very odd. Okay, 0.1. 0.1 separated from the build plate, leaving its raft behind. The supports separated from the model, but the interface layer is quite strongly bonded to the model itself. So we'll try cleaning that up, but I don't have very high hopes for it. And then 0. Oof. Okay, 0 left its raft partially behind. It did separate pretty easily, but held on a little bit better than some of the others. Okay, trying to separate 0 from its supports. And, okay, interesting. So, separating the support from the model caused a failure, similar to the strange model defects that we've seen with some of the other tests, where the nub has come completely off. The interface layer, one layer of the interface did come off cleanly. The other stayed pretty strongly bonded onto the test model. And if we try to break that support off, it does come, but it's bonded pretty strongly. I don't know if I would recommend that. So something very odd is happening here. This model failure is very strange. All right, let's see here. Let me try to, first of all, let's clean up this these rafts that are bonded to the plate. Okay, that's coming off pretty easily. So not a huge concern here. That raft I think is pretty, oh, spoke too soon. I was going to say it's pretty easily removed. Yeah, this isn't bad. This isn't bad. It's not as easy to remove as some of the others, but it's not bad at all. There we go. This probably would be a little bit easier to remove if I blasted it with a little bit of cold to try to shrink that PEI a little bit more. This material feels a little bit like PETG. It's like a kind of semi-brittle PETG. Maybe it's a PETG PLA hybrid of some kind, alloy. Yeah, there we go. All right, so got all those rafts off. Not bad. That was not too bad. I don't mind doing that. I think that it held pretty well, and yeah, wasn't too difficult to remove. So that's good. All right, we'll start with 0.9. So 0.9, there's nothing to clean up. It just looks bad. So 0.9, 0.8. All right, we got a couple little dots here that we can clean up with 0.8. Okay, that's bonded pretty strongly in there. Already at 0.8, that's unusual. Yeah, it did come off, but not easily. All right, let me grab some pliers. All right, so I would say that this is probably not a great choice for supporting TPU. It just randomly bonds way too strongly. The quality of the model is not particularly great. And we have these odd defects. Yeah, those seem fine. Which leads me to believe that this is just not a great choice of a material. That came off easily. 0.7 here. 0.7? Yeah, 0.7. 0.7's looking a little bit better, but it does have this defect. Look at that. It just peels right off. Weird. 0.6 has one little dot. It came off easily. Okay. 0.6 is in pretty good shape. Pretty happy with that. A little collapse there. Finishes okay, but not great. Okay, 0.5. 0.5 looks the best, but still not perfect. It's in pretty good shape otherwise, though. No real significant bonding. 0.4 has a little bit of bonding. That came off okay. Yeah, that's on pretty good. Okay, not terrible. I think 0.4 is serviceable. Oh, but we have that same failure. Look at that. Yeah, some sort of layer adhesion issue on that specific layer where the interface is. Really weird. So 0.4 is a failure. Okay, 0.3 left its whole interface on. Okay, that. All right, it's coming off in sheets, but this is definitely at the point where I would say I'm not going to recommend doing this because if you have supports that are not easily accessible, they will be very difficult to remove, even if we're successful here. Okay, yeah, we're getting there. It's a lot of work. Yeah, if you've got a straightforward support, you could potentially do this 0.3. Looks like we have that same failure. No, it's definitely got some faults in there. Those little artifacts, holes, but it's not detached like some of the others. So that was a lot of work to clean up relatively. I don't think I'm very happy with that. I would say probably stay away from 0.3. Here's 0.2. 0.2. 0.2 actually separates a lot more easily than 0.3 does. Might be a certain level of luck to that. A similar kind of bad layer adhesion on that interface layer. Well, the finish looks really good. Boy, that's too bad. All right, 0.2. All right, so 0.1. Well, bonding on 0.1 is really strong. Yeah, that's no good. That's no good. You don't want to clean this up. Yeah, that's going to be a real pain. Oh, there we go. Came off on a little bit of a sheet. Yeah, I would say that this is not worth it. 0.1 is too much work and too high risk. I would not use this as an interface. Except for in the most simple, most basic support scenario. How's that interface layer? Oh yeah, we got a little bit of a separation there. It's starting to come apart. Yeah, okay. And 0. 0 was the failure. So I'm not even going to try to do that one. Okay, so I mean, look, of all of these, I think 0.5 is probably our best result. But it's not a very good result. So this is not a great choice of a material to use as a support for TPU. Okay, here's a test that I did not have particularly high expectations for. This is supporting TPU using polycarbonate as an interface layer. Specifically, I'm using a polycarbonate made by Polymaker. It does have a particularly high print temperature, and it requires a very hot bed, and the slicer automatically chooses to heat the chamber a little bit. And so we do have some of the issues that we have with some of the other higher temperature support materials, like stringing, oozing, a little bit of deformation. So it's probably already not a great choice for a support material, just because it's going to cause defects in the model if you're printing it with TPU. Nevertheless, how does it work as a support material? Let's find out. Looks like the priming tower didn't want to stick very well to the bed, but that's okay. The rest of it stuck quite well. All right, let's remove 0.9. 0.9, this actually was pretty good. 0.9 removed easily from the bed. The raft is intact. Let's separate that from the model. Yeah. Okay, so it's separated from the model quite easily. Looks terrible at 0.9, but that's to be expected. Actually, it probably looks the worst of any that I've ever seen. Really interesting little defect there on the side. Looks like a little bit of a hole. I'm guessing that that's probably because the TPU melted so much as a result of the very high temperature for the polycarbonate that the surface just like essentially dripped right off. So I wonder how much of that is going to be an issue once we get to the lower Z distance. Okay, 0.8. Raft came off with the print. The print separates very easily from the support. It does not look very good. Okay, so far so good. Point 7. The raft came off and was intact. It separates easily from the model. The print quality is still quite bad, although it's starting to improve just a little bit. Point 6. Point 6 separated from the build plate easily. The raft is intact. It's separated from the model quite easily. And the model surface is actually starting to look pretty good. We've got a little bit of an improvement there. That's actually not bad. That's not bad. Better than I expected already at 0.6. 0.5. The raft detached from the print bed easily, and the supports detached from the model very easily. The model quality appears to be about the same. Okay, 0.4. Again, the raft detached easily from the bed. Interesting. The support is a little bit more work to remove from the model. There's like just a couple of places where it's starting to stick. Yeah, there we go. Yeah, it's adhering a little bit better than I expected. But at 0.4, that does not look too bad. That's a pretty nice 0.4 as far as 0.4 layers go. Not bad. Next is 0.3. 0.3 held onto the bed a little bit better than the other prints. This may be because of uneven heating on the bed. It's also holding onto the model quite well. I'd say about the same as the 0.4. And the finish looks pretty good. Pretty good. About the same as the 0.4. Next is 0.2. 0.2 removed easily from the bed. Okay, it's actually adhered pretty well to the model. This is a little bit of effort to get off. But I would still trust that. I'm not too worried about that, even on a large, complicated print. I think that was pretty easy to remove, and I wouldn't worry too much about it. Finish looks pretty good. Very happy with that finish. You know, except for the fact that we obviously have, you know, the defects from overheating the model by using TPU. So, you know, lots of stringing, lots of oozing, but that finish looks actually quite good on the bottom surface there. Yeah, looks good. Looks pretty good. Okay, 0.1. 0.1 removed easily from the print surface. The model is adhered very well to the supports, and it's quite difficult to remove. I may have to remove my gloves to do this. No, I got it. Okay, we do have some pretty strong adhesion. The bonding is strong enough that it looks like it's going to leave some remnants behind. Actually, that does appear to be peeling off. Yeah, that's on there pretty good. Yeah, I've got a pretty strong adhesion here. But it came off. There's a little bit of polycarbonate left behind. It's a little bit difficult to see because of the color of it, but there's just a couple little strands in there, so I didn't quite get a clean peel off, and so this will take a little bit of post-processing in order to clean that up. So maybe 0.2 is a better choice than 0.1. The quality of the surface is pretty good. And then 0. 0 removed perfectly from the bed. It actually felt really good. But separating it from the model is not trivial. That's on there pretty good. All right, gloves are coming off. All right, gloves are off. Let's see if I can get that to separate. Now that is bonded extremely well. I would say that this is not a trustworthy support at 0. I don't expect that you would be able to separate these in a complicated or larger model. Certainly not like this. Let's see if we can do a little bit better with some tools. The first tool that I want to try is this BQ scraper. It's really intended for print surfaces. It is a razor blade, and so this is probably not the safest thing in the world to do. Maybe it's not a good idea to try this at home. Yeah, this does not feel particularly safe. I was able to get the razor blade into the interface layer, and giving it a little bit of a twist is helping to separate it. Perhaps working it around in a circle does appear to be starting the separation. It certainly is helping. Yeah, this is slow but steady progress. If this model was a complicated shape, this would not be a possibility. And so, you know, I would say that this is probably a really bad choice unless your model has an extremely straightforward interface between the model and the supports. So for an organic shape, this would be a terrible choice. Almost all the way in. Yeah, and this method is a terrible method. Definitely not a good method to replicate at home. The odds of slipping and accidentally, you know, getting yourself are very, very high, especially with a razor blade like this. It just is not smart. I shouldn't be doing this. Looks like I've got a pretty good cut all the way around. Let's see if I can get the material to separate now. Okay, yeah, because of the flexibility of the TPU, it is now starting to come apart, but not in a single piece. It's crumbling. Okay. All right. It's two. All right, I've got all the pieces off. Let's see. You can see them. But the polycarbonate is still bonded quite strongly to the model. And the surface that I'm getting here, it might look pretty good on the camera, but it is actually not. It's quite a dirty surface. We'd have to do quite a lot of cleanup if we wanted to use this part. Let's see what that cleanup would actually look like. First of all, just peeling off that polycarbonate. Wow, that is such strong material. Yeah, that does not come off easily. Let's see here. So if I wanted to get that polycarbonate off, I would want to go across the support lines and just detach it from the surface in the few locations that it actually makes direct contact with the TPU. Yeah, even still, just not that easy to clean up. Yeah. Okay, so that did work out all right. Let's see how this one looks. Yeah, no prayer. There's no shot at cleaning up the rest of this. This is just not worth it. Yeah, zero Z separation is not recommended. This is a fail. I don't suggest using polycarbonate this way. And in fact, polycarbonate's probably not your first choice when it comes to support materials for anything. It would have been a big surprise if it worked with TPU particularly well. It's not the right material. If you had nothing else except for polycarbonate and you needed to print a complicated TPU model, could you use it? Yes. Not at zero separation. I would guess you probably want to shoot for something around 0.2 separation, and you got to be prepared to see some real warping from your model, and this stringing and oozing as well. I wouldn't be very happy with that though. Okay, and here's our different finishes. We've got 0.9, 0.1,
0.8, 0.7, 0.6, 0.5, 0.4, 0.3, 0.2, and 0.1, and here's our 0. The 0 has a lot of polycarbonate remaining on the interface layer, and the interface is extremely rough. The 1 has a little bit of polycarbonate on there, but the 1 and 2 are nearly indistinguishable. 2 doesn't have as much polycarbonate left behind on it. That's probably the one that I would do. 0.3 has a little bit of defect related to the Z separation. It has some polycarbonate still stuck to it. So this is probably where things are kind of starting to fall off in quality. I would say number 2 is probably the best of these options. So 0.2 separation for polycarbonate is a good choice if you had to use this material to support TPU. As you can see, I've laid down a pretty hefty coating of PVA glue stick in order to try to ensure that I'll be able to separate these models from this print surface. Otherwise, they may be permanently bonded. That would be a really bad thing. So we've got 0.9 millimeter separation going down to 87654, 321, and then 0 separation. In this particular case, using TPU as a breakaway support, this is almost certainly going to be a single piece that we won't be able to get this apart, not even with, pliers. This is going to be pretty stuck together, is going to be my guess. So let's start with 0.9. Let's see how easily it removes from the print surface. It's on there very good. Okay, it did come off easily. It's a little bit of work, but not too bad. And the raft came off cleanly. Let's see how much effort it is to remove the model from the support. Okay, it did come off. It was a little bit of effort, but the quality of the model, that first layer looks like really, really bad. Very low quality. So 0.9 worked, but that first layer is not good. This is what you could get from any printer, right? 0.8. 0.8 was difficult to remove from the build surface, but it did come off. And 0.8 is adhered pretty well to the model, but I was able to remove it. That quality is quite bad as well. Point 0.7. 0.7 did come off the build plate. It was a little bit of effort, but not too bad. And 0.7 did separate from the model. It actually came off more easily than 0.8. And although it's an improvement, the quality is still not what I would consider to be acceptable. If this was the best that I could do, I would probably choose a different material to create my model, or find another way to print it so that it doesn't require supports. 0.6. 0.6 was on the build plate pretty significantly. Did not want to let go, but it came off cleanly. 0.6 is pretty strongly bonded to the model, but it was separable, and that quality is definitely an improvement. Again, I would probably still not be happy with this. Point 0.5 came off the build plate more easily. The raft is intact. 0.5 is some work to try to remove the support from the model. But with a little bit of work, hey, that actually doesn't look so bad. Yeah, that quality's okay. This is maybe as good as we're going to be able to get. Let's see how 0.4 looks, but that is looking pretty good. Yeah, there we go. Nice focus. Okay. It's 0.5. 0.5 may be workable. 0.4 is really on the build surface. Oh, okay, it finally came off. 0.4 came off. 0.4 is quite strongly bonded to the model. Okay, but I did get it off, and again, another improvement in print quality. That's looking pretty good. 0.4 might be acceptable, depending on your circumstances. 0.3. 0.3 is very strongly bonded onto the build plate, but it did come off. And separating the model from the supports. Oh no. I'm going to need to remove the gloves for this. That's it. I think 0.3 is as far as we're going to be able to go. 0.3 is permanently bonded between the support and the model. We'll try some pliers. Okay, I use pliers to try to drive the flat nose into the interface layer and then twist and separate. There's no prayer. No prayer. Nope. That ain't going nowhere. Yeah, this is not going well. No separation. This is permanently bonded. I think that we've gone as far as we can go. Let's see how the other ones look. I always wear a glove whenever handling my print surface. Oils from your skin are not good for PEI, and it's okay if you do get them on there, but you'll have to clean it with soap and water later. And I'd rather do a couple more tests before I have to clean it. Oh, God. 0.2? Okay, 0.2 did come off. All right. I'll lose the glove again. See if there's any chance of getting 0.2. No, no chance. 0.2 is definitely on there permanently. 0.2 is no good. Let's try 0.1. I think we already know our answer. 0.1 came off the build surface easily. Nope. 0.1 is definitely bonded. No surprise there. 0.1 is definitely not going to separate from the support. And 0 being the special case. 0 separated very well from the base. This kind of 0 separation tree support has a very interesting raft that's unique to that Z separation. It's quite good. See if there's any chance of getting this apart. None. No, that is permanently bonded. That's not going anywhere. Yeah. Yeah, that's toast. Okay. Nothing from 0. Okay. Okay, let's get a good look at each. Here we have 0.9. Actually, 0.8. 0.7. 0.7, 0.6, 0.5, 0.4, 0.3 did not separate. 0.2 did not separate. 0.1 did not separate. And 0 did not separate. So what's the takeaway? I think that, even though 0.4 has the best finish and it did separate successfully. So what's the takeaway? I think that even though 0.4 has the best finish and did separate cleanly, I would probably recommend using 0.5 if you had to use TPU to support TPU for breakaway supports. Because if your print is large and complicated and has organic shapes, if it's not something as straightforward and flat as this little puck model, you may find that at 0.4 you're getting significant binding between the supports in your model. At 0.5, the finish is almost as good as 0.4, but it separates a lot more easily. And so for the safety and sake of your model, so that you don't end up in a position where you're losing a full print in the case that you over adhere and have too much binding like we do here on 0.3, I would suggest giving yourself a little bit of buffer and going with 0.5. The finish is close enough that it is acceptable without risking potentially ruining your model.
Okay, we've got ourselves another little failure here. This is trying to use ASA as an interface material to support TPU. And what the printer seems to be upset about is that there's some sort of extrusion pressure issue. It seems to think that the nozzle might be clogged. So let's watch it for just a moment here. While we wait for this to go, a few words about ABS and ASA. So, oh, failed again. Extrusion resistance is abnormal. The extruder may be clogged. Please refer to the assistant. After troubleshooting, you can select resume to resume the print job. I was trying to clean up the nozzle. Oh, it's actually going to attempt it? Nope, it didn't. Okay. Okay, so yes, what appears to be the case, the reason that this failure happened, I believe, is that the chamber and bed, and obviously the nozzle with the ASA all need to be of a particularly high temperature in order to print the ASA. I'm going to stop this right now, air this out a little bit. I think I'll probably have a little bit of a cleanup job to do here in order to get that nozzle unclogged. So the super high temperature may have caused the TPU to melt past the heat break and get clogged in the extruder. If that's the case, which I imagine that it is, then essentially what we've proven here is that ASA and TPU just don't mix, and you shouldn't attempt to print them together. That I think would be unsurprising. A few words about ASA in general. I hate it. I hate ASA, and I think that there's a lot of makers out there who would think that this is a hot take. They love ASA and ABS. They would say that ABS and ASA are cheap. They are They print very, very quickly because they have a rapid glass transition. They cool very rapidly, and so they're easy to print on overhangs. But they have 1,000 problems. And yes, I know that Legos are made out of ABS. I get it. ABS might be an excellent material to use if you're planning to injection mold your part. It can be very robust, but 3D printed, it's terrible. First of all, it is a styrene, and honestly, that's not even the limit of the terrible chemicals that are in both ABS and ASA. You don't want to breathe their hot fumes. They're carcinogens, they're toxic, they're just super bad for you. So if you're going to print with ABS or ASA, or high impact polystyrene for that matter, you really want your printer to be enclosed. You want it to have a really good air filter. And ideally, you want it to be in a place that you don't spend a lot of time, like, for example, a basement, right? Even in the case where you have a basement, like I do, where you can leave your printer, you really also want to be able to vent that space out very easily. You don't want these like VOCs hanging out in the air when you come down here and breathing them in. In fact, I probably shouldn't be just standing here just talking and breathing while I'm looking at this. So that's the first problem. The fumes, obviously not great. The second problem is that if you can get ABS or ASA to bind to your print surface, it will often bind just entirely too well. So the challenge is that with ABS and ASA, as those materials cool, they cool unevenly and they shrink, and that causes dramatic warping. So even on like a normal print that is relatively small, the difference between one side of your print and the other side of the print when printing in just ASA may cause the ASA to release from the bed and start curling upward, and you get all kinds of crazy failures when that's the case. But when it does adhere to your print surface, it can over adhere like crazy, and it can be extremely difficult to remove from any print surface. And so first of all, a couple of tips. The first thing is always put down glue stick, which is PVA, right? So PVA is also a good support material. It's kind of funny to think that I need to use PVA to support my support material, which in this case is ASA. So yeah, PVA is a good choice to coat your bed with, because first of all, it provides a little bit of additional adhesion to the ASA and ABS. It also, as it cools, provides a little bit of a material that the ABS and ASA can kind of pull away as you separate them from the print surface. So it not only acts as a good holding agent, it also acts as a good release agent. But that's super annoying, right? You don't want to have to prepare your print surface, especially something like PEI, which is designed very specifically to hold onto things while hot and release them when cold. Basically, most other 3D printing materials work just fine with PEI. There's no need to pre-treat the surface the way that I've had to here. If you do end up in a situation, though, where your ABS or ASA has adhered to the print surface too strongly, my tip would be that you should first heat the bed. Get the bed as hot as you can possibly get it with your printer spec. Once you get it up to maybe 100 degrees Celsius or so, then gently use a scraper to try to remove the material. I found that basically nothing else works. So yeah, the other one small piece of advice is that when using PEI as the print bed for ASA and ABS, try to use non-textured print surfaces. The reason is that the ABS and ASA, it's so hot in this chamber and the bed is so hot that it actually melts into the cracks between these textured surface, rough surface edges. And when it gets into those cracks, that's when it really over adheres. So that's when you're going to have difficulty releasing your print from the print bed. So using a flat print surface is generally going to be a little bit better than something like a textured print surface like this. And finally, the last reason that I hate ABS and ASA is that the layer adhesion just is absolutely terrible. It's just not a good material. Honestly, the materials that we have available today just surpass them in every single way. ASA is a little bit easier to work with than ABS is, and as you can see, it's still a complete and total failure in this case. So anyway, I generally avoid it and suggest that you do too. The one thing that it does do that's particularly cool is ABS and ASA both dissolve in solvents. And so you could potentially use the vapors of acetone, for example, to melt away layer lines on a very high detail model that you print out of ABS or ASA. That's pretty cool. It certainly adds a new capability, but it's not worth it. There are so many other ways to kind of get the same result. I can't recommend it. That feature is interesting, but there are other materials that also dissolve in solvents that may be worth playing with if that's the effect that you're looking for. I just don't think that ABS or ASA does anything so well that it's worth the headaches that come along with it. Okay.
This test was trying to support TPU using high impact polystyrene. And it looks like the raft from the high impact polystyrene did not adhere to the TPU at all. And as a result, we had a failure. So just to verify that, oh yeah, just very gently kind of sits on top of it. Oh, and even the high impact polystyrene doesn't stick very well to the build surface. So, yep. Here we go. That's a failure. So high impact polystyrene is often a recommended support material for filaments like ABS and ASA, but I do not like it. The premise that people often suggest it under is that it supposedly dissolves in delaminine. It does not dissolve in delaminine. I don't know how this rumor got started. Even if you had like a vat of delaminine, which you don't want to have, right? I mean, delaminine it's a solvent that, is made from orange peels. And so, it's whatever, maybe a little bit less harsh than some other really terrible solvents. But that doesn't mean that it's not harsh. I mean, it is still pretty nasty stuff. And having an open vat of it in your workshop is kind of a fire hazard. So look, you shouldn't take delaminine lightly, but the reality is that if you were to stick one of these little discs into delaminine, it wouldn't dissolve away. It would become a little bit more brittle, and maybe that makes it a little bit easier to remove from ABS, potentially if ABS doesn't also dissolve. But I've got some bad news for you. Both ABS and ASA will also dissolve to the extent that high impact polystyrene does in delaminine. They both break down basically the same. They become very brittle, they kind of crack, and they definitely bond to each other extremely well. We're going to do a test of that eventually, and when we do, you'll see that high impact polystyrene is a terrible choice to support ABS and ASA, and it's also apparently a terrible choice for TPU. So, yep, take that high impact polystyrene and throw it in the garbage. Or I don't know, do something else with it. Just not this. Okay, we've got another test failure. This one is Bambu's support for nylon, attempting to support TPU. The extruder has clogged again. I'm getting the same error message as I did for the other high temp material, saying that the resistance is abnormal. And so what appears to have happened here is the high temperature of the chamber and the build plate that's needed for this support material has caused the TPU to soften inside of the extruder above the heat break. And that's now causing a jam. The TPU cannot be extruded down into the hot end.
And so in order to fix this, what we're going to have to do is abandon this print. We're going to give up on it. We're not going to rate any of these results because the models all failed to finish. So it doesn't really make any sense to even say if this would be a good support material. We're just going to say, nope, it's a failure. Print did not succeed. And then I'm going to have to do a cold pull out of that nozzle in order to get that TPU out of there. Hopefully it doesn't require that I actually disassemble the entire extruder assembly in order to get the ball of TPU that's melted out of there. So, all right, that's a failure. So Bambu support material for nylon is not a good choice for TPU supports.
Okay, it looks like we have a failure. So this attempt was attempting to support TPU using yxPolyer support material. This support material is intended for ABS and higher temperature filaments, which TPU is not one of. That's not that surprising. Print temperature, though, is 220 to 260. The problem, I think, is the bed temperature expectation of being 100 to 110. That's way too hot for TPU. And the effect was that the raft did not stick to the build plate really at all. Came off pretty easily. So that's a failure. Not a good choice for TPU supports.